Welcome to AP Environmental Science. In this video, we are going to briefly discuss the idea of carrying capacity, and this topic is discussed in Module 18 in your textbook. Here are a few terms that you'll want to make sure you understand the definitions of because they are used to describe this overall concept. Now, carrying capacity is that maximum population that a particular environment can support, and this is based off of how many resources are available, how much competition is taking place in that particular location, and what the demand is on those resources. Overshoot is what happens when the population is above the carrying capacity, and die-off is what happens when the population is so high that there's now not enough resources, so the population starts to decrease. And this could be because of famine or disease or some type of density dependent factor, so some type of conflict that's happening. And the unstable equilibrium is just talking about the idea that that population does not hold steady at a specific number. It fluctuates a little bit above and below carrying capacity. Now I'm going to show some visuals on this to help you really understand what these terms all mean. So here's a graph that shows over time our population's growing exponentially, it's doing great, it has a ton of resources. Now all of a sudden it reaches that carrying capacity line. But a population can't just put on the brakes and stop immediately. It goes through a little bit of overshoot. So it takes a little bit of time for the species or the population to realize that, hey, there's too many of us. We are using more resources than are available, and our population is starting to starve, or there's starting to be a lot of pressure on our overall population size. So now individuals are starting to die pretty prematurely. So the population as a whole will start to decrease, and that's our die-off period. Now the population will die down and it will dip below carrying capacity. And when it's below that carrying capacity, now there's an abundance of resources. So there's enough so that way the individuals can start surviving, being a little more healthy, and having some more babies, and that population will start to come back up. So this fluctuation above and below the carrying capacity, that's our unstable equilibrium. However, over time, sometimes this carrying capacity can start to become degraded due to some types of pressures against the resources that are available in that location. So perhaps humans are now chopping down the trees in that particular forest ecosystem, and now that particular species does not have as much habitat available. So that means their carrying capacity is going to start to go down, and as a result, their population will also decline. Feedback loops play an important role in this idea of unstable equilibrium. And I want to remind you that there are two types of feedback loops. We have positive feedback and negative feedback. In positive feedback, I like to use the description of change leads to more change. And this is the idea that you start at some type of situation, and over time, because of some particular event, you get sent on this trajectory that shoots you very far, either up or down, so far away from the condition that you started at. Negative feedback loop is the idea that change leads to less change. So what happens in negative feedback is the population, or whatever condition you're looking at, becomes more stable over time, and it just is constantly cycling back and forth between the same situations. Here's a closer look into how feedback loops relate to carrying capacity. So with positive feedback loops, change leads to more change. This is that initial part of population growth. This is when there's that big J-shaped curve going on with the exponential growth. So think about mice have a lot of offspring. Now if we take other limiting factors out, there's a positive feedback loop at play here. So when you have more offspring, you're going to then have them grow up into more adults. And when you have more adults, they're going to produce more babies. And those extra babies are going to grow up into more adults. And those more adults are going to produce more babies. And this cycle keeps repeating itself, and we are getting further and further and further out of whack from where we started. So this is that exponential growth. Now, the flip side is negative feedback. So negative feedback, change leads to less change. So we have some type of environmental factor that really limits that population growth. This is what holds a species at carrying capacity. So if we take that same example but throw some limiting factors in, we start to see this equilibrium develop. So again, you have mice that have a lot of offspring, which means you have more adults. But when you have more adults, you have more consumption of food. And when you have more food being eaten, that means there's less food available. And when there's not as much food available, then the adults are going to start having fewer offspring. And when you have less offspring, they're going to grow up to be fewer adults. And when you have fewer adults, then there is not as much food being eaten. And when there's not as much food being eaten, that means there's more food available to those individuals that are currently alive, which means there's going to be more offspring. So you start to see this loop together, but it holds steady at equilibrium. So in summary, you should be able to use the terms carrying capacity, overshoot, and die-off, and be comfortable explaining environmental situations, particularly population ecology, using those terms. You should also understand how feedback loops relate into carrying capacity. I also want to briefly remind you that R-selected and K-selected species tend to have a little bit of different population growth patterns. So R-selective species, those are the species that have that very strong initial population growth and don't tend to have a lot of environmental factors limiting them, at least early on. When they do have factors limiting them, they're density independent and they're kind of these boom-bust populations. They see these really big swings around that carrying capacity. K-selected species, on the other hand, those tend to have that negative feedback loop that holds them right at their carrying capacity, and they don't have a lot of fluctuations. Now, if you have any questions of the information from this video, please send them to me right away. I'll get back to you as soon as possible. And I hope that as you watch this video, you were able to learn something.